So here's question 4. Now question 4 says, in the diagram, the equation of the circle centered at B, so saying that B is the center of the circle, is given as the following equation. So we can clearly see that the equation is given in the form as, it's going to be ax squared minus bx, plus bx plus cy squared plus dy equals to 0. So that's some format that we have over here, but let's not focus on that for now. We are given an equation of the circle, of the huge circle that we have right there. Now they give us the following information over here. They say that ds and PA are tangents to the circle D and A, right? So basically they're saying that these lines here are tangents because it's touching the one point on the circumference of the circle. There's also one of the other tangents touching the one point of the circumference of the circle. Okay, so they're just naming those tangents. Okay, then they say A is the y-intercept of the circle. So A over here is the y-intercept of the circle indeed. ds is parallel to the y-axis. Okay, great. So there's cool information that we know that this is parallel to the y-axis. Okay. And now, so I'm going to write down this information here. So I'm going to do it in red, because it's always good to put down the information that you have so it aids you when you answer the question. So we have, so over here, right? So whenever you are told that you have a y-intercept, I want you to do the following. A will then have the coordinates of 0 and y. Because we know that any point on the y-axis, the x value will be equal to 0. And any point on the x-axis, the y value will be equal to 0. That's what we should know as a grade 12 student. Okay. Now we have, so we have point C, which has coordinates of 1 and 1 over here, is a point on the circumference of the circle. So just saying it's there. CD and DE are chords of the circle. So CD and DE are chords that are on the circle. Okay. BE is, if drawn, is parallel to DS. So BE, if drawn, so basically if we were to draw it like this, therefore it will be parallel to DS. Okay. So that's exactly what we have. So therefore, BE is also then parallel to the y-intercept. The y-axis. And then we have the last piece of information, which is the smaller segment of the circle on the chord is DE. So they're saying this over here. So they have a shaded region, so I assume there's probably going to be a question based on find the area of this. And I love these types of questions where they actually say find the area of the shaded region. Oh, here we go. I see it over here. Okay. So let's start with the questions now, okay? So now we have 4.1, right? So from the information, we've already given all the information. 4.1 says the following. Show that the coordinates of B is 4 and -3, and then show all your calculations. Okay, this one's is a really, really simple one. So let's do this together here. So our goal over here, right, is to actually to prove that this coordinate is true. And to do that, what we are going to do is the following. So we're going to say that we have 4.1, and then how we're going to do this, right, is we are going to look at this equation right here, right? This equation there. And what we can see over here is that if we want to prove that this coordinates are true, what we are going to do over here is we are going to take this equation, right? So we're going to say x squared minus 8x plus y squared plus 6y equals to 0. And over here, what I'm going to be doing is I'm going to, okay, so let me just move this a little bit here. And what I'm going to be doing here, right, is I need to manipulate this formula such that we can get these coordinates over here. So how am I going to do that? Remember, on this side, remember that this would have actually been, so the right-hand side would have consisted of the radius, right? So the radius is on that side. And we know that the radius is basically just whatever squared, right? So we know it's going to be the squared version of these coordinates now. Now that we look at this again, right, we are going to add 4, it's going to be 4 square over here, plus it's going to be the negative 3, that dog, all squared, and then we are going to get over here an answer over here, which is going to be 0 plus, this is going to be 16 plus 9. Okay, where was I? Sorry. But remember, when we are dealing with an equation, what we do on the one side, we have to do on the other side. So we have to do the same thing over here, and then we are going to do this. So it's going to be x squared minus 8x, then plus, so we know that the 4 over here is the x coordinate, and the negative 3 is the y coordinate. So let's put the, now we're gonna add 4 square, right? And now you're gonna see why this is actually useful. The reason why we're keeping it in the square. Plus y square plus 6y, and then we're gonna have the other coordinate, which is going to be plus negative 3 square, right? So now what we're going to be doing over here is we are going to simplify this over here, which we're going to get 25 on this side. And then what we can see over here, right, is we actually have 2 trinomials adding each other. Can you see that? Now we can just factorize these. So we can see that this first trinomial is going to be x. We have a negative and a negative, so it's going to be a negative and a negative in the brackets here. So it's x minus 4. And note over here that it's 4 squares. So it's 4 squares broken up into 4 and 4, right? So it's 4 minus 4, and then it's x minus 4. And it's going to be plus, and then you can see this trinomial over here. This is broken up into 3 and 3, right? Over here. So initially, right, so let's say if we were to expand this, for example, I'm just trying to show you, if we were to still expand this, we would get the following. This would actually look like 9. And we know that 9 can be broken up into 3 and 3. So I think it probably would have been a beneficial way to actually, it wouldn't have worked if we actually had the negative in it. So we should have actually just taken it out over as, like, let's say 16 would have been over here, and then we would have had 9 over here, which could break up over there. So we're going to have y minus, sorry, it's going to be plus, because we have plus and a plus and a plus here. It's going to be y plus 3, and then y plus 3. And then we can simplify further. We can actually write this as x minus 4 all squared plus y plus 3 all squared is equal to 25. And now from here, when we're trying to find the coordinates, right? So which coordinates are we trying to prove? We're proving b. So b, in our case here, would have the coordinates of, and remember when we're taking out the 4 here, the negative 4, it's going to become a positive 4. And then if we are taking out the positive 3, it's going to be a negative 3 over here, right? Just note that we're taking it out of the brackets. We are letting these brackets equal to 0. Okay, and then there is our proof. Therefore, b has the coordinates of 4 and negative 3. So now we're on to the next one. So 4.2.1 says, determine the equation of the tangent ds. Okay, so the tangent ds. Now let's look at ds here, right? We can see it's a vertical line. So therefore our vertical line, so I'm going to write over here, 4.2.1, our equation of our vertical line should be x is equal to, because you can see it intersects the x-axis, right? So therefore it's going to be our x value. But we need to determine what is our x value. And what we know over here, right, is that from our other equation, we had the radius, right? So we had, I think it was x minus 4 all squared plus y plus 3 all squared equals to 25. Now our radius is just essentially the square root of whatever number is on this side over here, which is the square root of 25. And therefore our radius is equal to 5 units. So therefore, if we were to draw our radius, right, from B to D over here, we would have an answer of 5 units, right? And this would also be 5 units because these two are radii. Now, over here, because that is 5 units, we're just going to take the x distance from here, which is going to be positive 4, right? So this was positive 4, so let me actually write it like over here. So it's 4, and it goes all the way here, right? And then we're going to add the 5 to get this certain distance here. So x is actually just going to be equal to the 4, which we had over here. Remember, this coordinate over here was at 4, positive 4, and we are going to add the radius, because remember, we need to add the distance here. And therefore, our equation will be x is equal to 9. So now we have question 4.2.2. We need to determine the length of the chord CD. Now CD is over here, right? So we have C over here, and then D is all the way here. Okay, and what is our coordinates of D? We know that our coordinates of D, we can see it's in the same y level, so our y value is going to be the same as it was in B. So but remember, we know that the x value is 9 that we've determined, and the y value is also going to be -3. Right? Now that we know that, and we also know what C is, therefore we can actually determine what our length of our chord is, because we have two coordinate sets. So we're going to say that 4.2.2 is going to be, now we say CD is equal to, and we're going to have our equation of our distance formula, sorry. So we're going to say it's going to be the x's over here, so it's going to be, let's say, 9 minus 1. So it's going to be 9 minus 1 all squared plus, and we're going to say -3 minus 1, which is going to be with our y's. Sorry, no, that's minus 1 all squared. And then we're going to close the third up. And then we're going to say here CD is then going to be equal to the root of 9 minus 1 all squared. So that's going to be 8 squared, which is equal to 72. Plus, and we have -3 minus 1, which is -4, -4 all squared, which is going to be equal to positive 16. So then we're going to have the following over here. It's going to be root 72 plus 16 is just going to be equal to 88. And that is that. Guys, I think I need to go back to school. I was looking at this answer here. That's 9 times 8. 8 squared is 64. I think I actually need to go back to school. And therefore, this would actually be the square root of 80. Because 64 plus 16 is just going to be equal to 80. Alright, cool. And that will be that much units. And we can actually simplify this third over here, right? So we don't have to end it off with third 80. What we can do is we can actually, okay, I'm not going to show you that method now. I recommend looking up nice breaking up methods. You can also write this as third 4 units, right? You can also write it like this. But I think let's keep it as square root 80, because once again, when we are in examination conditions, things will get stressful, and you'll be easily make mistakes, and you won't have this much time to, or confidence to break it up, unless you're the cool guy. But anyway, let's just move on to the next question here. Alright, so this is actually probably my favorite question. I was just analyzing it quickly. So we have 4.2.3 that says the following. The equation of the tangent PA in the form of y equals mx plus c. Great. So they want us to find out what is the equation of this. Now, this requires a lot of knowledge from what you've learned in circle theorems, right? So this is where this coordinate A came in clutch. Now we know exactly what the x value here is, and that is 0, because remember, it's a y-intercept. And any x value on the y-intercept, we're going to know that the x value will be equal to 0. So let's use this equation that we had. So we have x squared, so wait, hold on, give me a moment. I'm just going to write 4.2.3. Cool. So we have x squared minus 8x plus y squared plus 6x equals to 0. That is a y, sorry, my fault. So we're going to have a y over there. Okay, lovely stuff. And like I said, the reason why I'm substituting 0 into this one, because remember, it's a point on the circle. And because it's a point on the circle, we can actually include the circle equation. Because that's the point of intersection between the tangent line and the circle. So therefore, we can actually plug 0 into our circle equation. And this is going to be minus 8 into 0 plus y squared plus 6y, because we don't know our y value, right? Remember, we are trying to find out what is our y value. And I didn't even close this up, by the way. Okay, so now because we know that these are going to cancel, since it's 0 minus 0, which is just going to leave us with this over here, which is going to be y squared plus 6y equals to 0. And now what we are going to have is we are going to have to take out the common factor, and our common factor is y, and we're going to have y plus 6 is equal to 0. Okay, now from this point, remember that if we have like two brackets, right? So we have y, so obviously y is still included. We'll have a solution of y is equal to 0, or we'll have a solution of y is equal to negative 6, right? And the reason why it can't be y equals to 0 is because it's not on the origin. So by logic, we can actually say that the y value is going to be negative 6. So therefore, let's write that down. So we're going to write down over here that the coordinates of A is going to be 0 and negative 6. Okay, cool. Now that we know that part over here, let's use our other knowledge. So how on earth are we going to determine the tangent line here? Now, if we want to do that, we need to actually consider the following. If ever we have a tangent line, right, to a circle, we know that the tangent is perpendicular to the radius. So therefore, if I were to draw a radius from the tangent, the point of the tangent to the circle center, therefore we know that this angle here is 90 degrees, and this angle here will also be 90 degrees to make the straight line true. So therefore, we know that this gradient, so therefore the gradient of the tangent is perpendicular to the gradient of the radius. Okay, and we know how to actually deal with that stuff. So because we have the coordinates of A, we need to actually determine what is the equation of AB. Remember when I said the coordinates of the tangent, the gradient of the tangent, we don't know that yet, but we can find the gradient of the radius. We know that B has coordinates of 4 and negative 3, which I wrote there. So that's what we are going to do. So what we are going to be doing here is that we are going to find the gradient of AB. So we know that A has coordinates of 0 and negative 6, now that we have determined what the y value is here, or the y coordinate, and we also have B having coordinates of 0 and negative 6. And now what we're going to be doing is finding the gradient of that radius, of AB, which is equal to, and now we're going to name this set 1 and 2, so therefore it's going to be, set 1 is just that's going to be y1, this is going to be x2 and y2, and then we are going to have to substitute negative 6 minus, and then our y1, which is negative 6. Remember your brackets. And then we're going to have the x2, which is 0, minus that, which is going to be... Why do I make these silly mistakes? Okay, I apologize for that. I just realized what I did wrong. Don't make these mistakes in the examinations, please. This is 4 and negative 3. My apologies. I was thinking now, what on earth is happening here? Negative 3 is y2 minus, and then negative 6 is y1. There we go. Now that makes sense. I was thinking, why is it 0 minus 0? Okay, but anyway, now we're going to have, it's going to be x2, which is 4, minus x1, which is 0. And now the gradient of AB is going to be equal to negative 3 plus 6. So it's going to become a plus. So negative 3 plus 6 is just going to be equal to positive 3 all over 4. And that's our gradient of so that's our gradient of AB. And remember, now that we know our gradient of our radius, which is AB, now we can actually say that therefore the gradient of the tangent is going to be equal to, remember this is a positive sign, and if we are finding the gradient of a perpendicular line, we are going to flip the sign to its opposite, and we are going to flip the fraction to its inverse. Therefore it's going to go from 3 over 4 to 4 over 3. And there we go. That's the gradient of this line right here. Okay, now what we need to do is we actually need to quickly represent our equation. So it's going to be y is equal to negative 4 over 3 so far, x, and then it's going to be plus c. Okay, now we need to determine over here that we know our y-intercept is going to be negative 6, right? So because we know the y-intercept is negative 6, then therefore we can actually say that our c value will be negative 6. See these cool things. In these questions you really need to like break the information down. And it's always important to show your information on the graph, and that's exactly what I was trying to stress over here. That first put as much information into the graph as possible, and then you can start solving the questions. Because basically if you just start solving the questions, what the hell do you even know? What are you even going to start with? So that's why put in the information, and then therefore, and also please do not make those silly mistakes that I make. We all do make these mistakes, but when it comes to NSC, you really can't make these silly mistakes. Okay, let's move on to the next question. Okay, so I really love this question. Okay, I'm basically saying that for every single question. The area of the shaded segment. Okay, I really like doing these types of questions. So the area of the shaded region, and you're gonna love it too. Trust me, it's so much fun. Okay, so what we can see over here is we are going to start off with the following. We're gonna say 4.2.4. Whoa, that is not black. Here we go. 4.2.4. This is how we're gonna start, right? So what do we have over here first, right? We can actually determine the area of the... Okay, so we can clearly see this is a quarter of the circle, right? So we are going to say that the area of the quarter of the circle, I don't know how you want to represent the circle, but I would say of circle, so circ is going to be equal to, and remember the normal area of the circle is equal to pi times radius squared. But what we are going to be doing is we're going to find the quarter of that, so we're going to divide by 4, or we could actually multiply it by 1 over 4. So let's just actually divide it by 4, right? We're finding the quarter of that, the area of the quarter of the circle. And now we know that our radius is actually just equal to 5 units over there, and this is 4. And if we put it into the calculator, we get an answer of 19,634 ... and we'll have, I believe it is, units squared. So that's the area of the quarter of the circle. Cool. Now, what's the next thing, right? We found that, but we need to find the area of the shaded region. In order to do that, we need to find the area of the triangle and then remove that area of the triangle so that we can only have the shaded region left. And that is our plan over here, right? So in order to find the area of a triangle, we know that it's actually going to be the area of the triangle, which in our case over here, it's going to be BED, or triangle BED, sorry. And it's going to be equal to half times base times perpendicular height. And we know that if we draw our perpendicular height like this is going to be our perpendicular height. And we know that that is going to be the radius, right? So it is actually the radius. And the DE over here, right, is going to be, if we want to find the area over here, if we want to find our base, right, what we need to take into consideration is if we want to find out what DE is equal to, the reason why it's actually equal to the radius, which is equal to 5, is because remember we broke it up into a quarter of a circle. And if it is in that quarter, then these will be equal to each other. So that means over here, because of that, we can say that we can plug in half multiplied by our base, which is 5, multiplied by our perpendicular height, which is also 5. Then we're going to have triangle BED, and then therefore triangle BED is is just going to be equal to, it's going to be 5 over 2 times 5, which is equal to 25 over 2, which is actually going to be equal to 12,5 units square. And now what we have to do is we need to find the area of the shaded region. So area of shade, right, is going to be equal to, it's going to be equal to the area of the quarter of the circle. So the quarter of the circle being this entire area here, right? And then the triangle, which is this area here, that white space, which you need to actually remove that white space. So therefore, it's going to be the area of the quarter of the circle minus the area of triangle BED. And therefore, we're going to have, it was about, I think, okay, so it says here, 19,634, 634 dot 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 units, oh, let me not keep that, sorry, minus, and it's going to be 12,5, and then therefore the area of the shade is going to be that 19 minus our 12.5, which gives us a final answer of 7, so let's say approximately 7,13 units square. And that's the answer of the area of the shaded region. So now for 4.3, we have the following. So we have another circle with the center M and equation over here, which is going to be x plus 1 all squared plus y minus 2 all squared equals to 8 is drawn. Now we need to determine with an explanation whether the two circles will intersect or if they won't intersect. Okay, great stuff. Now the first thing we need to identify from these, right, is what do we compare? So M and B, right? We need to determine if they intersect or not. So what we need to first do is we need to find what is the distance between M. So let's say we have this circle, right? We don't actually know whether they intersect or not, right? Is there any intersection? So this circle has center B and this circle has center M, right? And we want to determine what is the distance between these two, and then we want to see the points, right? But we need to show with explanations whether or not they will intersect. So let's find what is the distance between M and B. So the first piece of information that we need is obviously the radius, the radii, right? Because once again, what we need over here is, so we're going to do this. And now the reason why I'm trying to find the radii, right? So I'm going to show you exactly why. So with circle B, we know the radius. So let me actually write down the coordinates quickly for circle B. The circle B has its center at 4 and negative 3, right? So 4 and negative 3. And then we have the M, which has its circle center at, you can see the positive 1 is there by the x, so therefore it's a negative 1. And there's a negative 2 by the y over there in the bracket, so it's going to be positive 2. And we can say over here that the radius, we know that this is 5 units, right? But what is the radius of this one? This is equal to 8, right? And we know that if this 8 is on its own there, we need to take this, the radius of that circle is going to be the square root of that side, which is square root of 8, which we can actually just write as the square root of 8. So that is the radius of the circle. Okay. Now, from this point, the reason why I want to do this, right? At some point, we want to prove that we want to determine if the two circles will intersect. And once again, I'm going to draw these circles over here. Let's say that we have two circles, they touch, right? And then they have M. I'm doing this again, I know, but I'm actually trying to explain here what approach are we taking here. We need to find the distance, right? And then once we find this distance, we need to find out if the sum of this radius for B and this radius of M, if they add together, right? And if the sum of the radius M and radius of B is going to be greater than the distance of MB, then therefore there will be an intersection. Therefore there is intersection. Right? But if the sum of the radius of the two radii is less than MB, there will be no intersection. Okay, because obviously then if the sum of those two lines are greater than the distance, then obviously they override each other. So let's actually get to the application of all of this. Okay, so when we want to find now the distance between the 2 points. So in order to do that, we're going to say that BM is equal to the square root of, we're going to name these y1, this is x1, this is x2, and y2, because we have the set 1, which is B, and then we have set 2, which is M. Okay, now y2 is equal to 2. Sorry, no, we're working with x first. x2 is equal to -1 minus x1, which is 4, all squared, plus, and now the y side, which is going to be y2, which is 2, minus, and then -3, all squared. And then we close the third up. And now we're going to say that BM is going to be equal to, so BM, is equal to, we're going to simplify here. -1 minus 4 is just equal to -5, and -5 all squared is equal to 25. Plus 2 minus -3, that's just 2 plus 3, which is equal to 5. 5 squared is equal to 25. Okay, and then we know that therefore BM is just going to be equal to the square root of 50 units. Also, this was also supposed to be units, and this is also units. Don't forget your unit of measurements here. So now, remember what I said over here. We need to prove that, let's see over here, right? Let's find the, okay, so we know that square root of 50 units, which is BM. Let's figure out what is the answer here. What is the square root of 50 equal to? It's equal to 7,07 units, right? So approximately 7,07 units, right? And the sum of the two radii, so the one radius, which is equal, so we're going to say the radius of B plus the radius of M is just going to be equal to, what is the radius of B? So it's going to be 5 units and 8 units respectively. So it's 5 units plus the square root of 8, which is equal to, if we put that on a calculator, it's going to be 5 plus the root of 8 equal to 7,83 approximately units. And now what we can see over here is that from this information, we can see that this value is greater than this value. Therefore, because the radius of B plus the radius of M is greater than the BM, therefore the circles will intersect. That is, why is it doing this? They will intersect. See if there's anything else. Did I even read this question fully? Yeah, I think I did actually. Yeah, determine with the explanation whether the two circles will intersect or not. So there we have it, the answer for number 4.3.